Back to my YouTube channel. During our first lesson, we learned about the definition for dimensional analysis. And we said that dimensional analysis is an equation used to express physical quantity in terms of its dimension. It's an equation used to express physical quantity in terms of its dimension. We also find dimension for some of the physical quantities. We're able to find a dimension for momentum, force, acceleration, pressure, kinetic energy. Yes. So today, our subtopic is uses of dimensions. Uses of dimensions. We have a lot of use of dimensions. Yes, the use of dimension. There are about 4 or 5. Yes, so I'm taking them one by one. Yes, I'm taking them one by one and explain it so that you will understand it better. Okay. Now, the first use of dimension is dimensions are used to find the units of a quantities. Dimensions are used to find the units of a quantities. And I hope when you say units, you know units. Yes. So dimension they are used to find units of a quantity. Units of a quantity. So if you have dimension, you can use that dimension to find the unit of that what quantity. To find the unit of what that quantity. Okay. So still on the first use of dimension to find the unit of a quantity. First example, that's example one. It says, find the unit of a quantity whose dimensions are MLT neg 2. So you should find the unit of a quantity whose dimension is MLT neg 2. Okay. So MLT neg 2, we are finding the unit of a quantity whose dimension is this. Okay. Now, the unit for mass is kilogram, that's kg. Okay. And the unit for length is what? Meters. The meter. Okay. Then the unit for time is what? Seconds. That's it. It's T negative 2. That's power negative 2. So this one as well, power negative 2. So this is the unit for that what quantity. Yes. So this is the unit for that quantity. kgmx to the power negative 2. And that's the unit for force. This is the unit for force. So how you can see that we're able to find the unit of a physical quantity by the use of what? Dimension. By the use of dimension. So that's why the one use of dimension is saying that dimensions are used to find the units of a quantity. So I was having a dimension for force, and that dimensions help me to get the units of a force. Okay. I think I have to clean the board for the next example. Okay, so still on the first use of dimension. Example 2. It says the dimensions of work or energy, which means the dimension for work. If you find the dimension for work, is the same as that of what? Energy. Mm. If you find the dimension of energy and you find the dimension of work, you get the same results. Okay. So the dimensions of work or energy is ML2T neg 2. Find the fundamental units of work or energy. Of work or energy. Okay, so that's the dimensions for work or energy. And you are supposed to find the units of that physical quantity. Okay, so ML2 T neg 2. T neg 2. Okay, so the unit for mass is kg, and the unit for length is meters. So it's L to the power 2, so to the power 2 as well. And the unit for time is seconds, and to the power negative 2, so to the negative 2 as well. How about getting it? Yeah. So mass, kg, length, meters, and but here is to the power 2, and time is seconds, but here is to the power 2, so you need power negative 2 as well. Okay. So this is the units for that physical quantity. But you're supposed to what, express it in proper way, because you don't have any units like that in physics. You don't have any units like that in physics. So you're supposed to what, write them proper. Okay. Okay, so I'm writing it in proper way. So kg m is negative 2 m. Yes. So this is the units for work or energy or energy. So the m, we are having two m. I just separated them. Yes, so one m is here and one m is here. They are hot. This one is multiplying this one, right? Yes. Okay, so this is the units for work or energy. So dimension, one unit of dimension is that to find the unit of a physical quantity. It's about what you use dimension to find the unit of a physical quantity. So you have used this dimension to find the unit of the physical quantities known as work or energy. Okay. Okay. So example 3 on the first use of dimension, still on the first use of dimension. So example 3, it says find the unit of a quantity whose dimensions are, so supposed to find the unit of a quantity whose dimensions are a m l to the power 3. Okay, so solution. Okay, there. Yes, so for mass, the unit for mass is kg, and the unit for length is meters. Now this is to the power negative 3, so it will be negative 3 as well. As simple as like that. Yes. So this is the units for this physical quantity by the use of the dimension to find the units of that physical quantity. Okay. So we are having L to the power 3, T to the power negative 2, M to the power negative 1, multiplying M times M all over L to the power 2. Okay, so let's solve this one before we find the unit of it as well. Okay, so we get L 3 T negative 2 M to the power 1 times. So multiplication, we add the powers. One is here, one is here. So we add the powers. So M to the power 2 right is over L to the power 2 is okay. Now L to the power 3, T to the power negative 2, M to the power 1 times M 2 L to the power 2. Yeah, so whilst the L to the power 2 is moving up, you introduce what? Negative. Because of the division sign here. Whilst this one is moving up, you got being negative. Yes, that's algebra. Okay. Now let's group them. For M, you have M, one is here plus 2, and one is here multiplying another M. So for multiplication, we do what? We add the powers. You have M to the power 3. Yes, because 1 plus 2. So you get 3. Okay. Then let's come to L. You have 3 is here, and you have negative 2 is here. The positive 3 is here, negative 2 is here. So 3 plus negative 2, you get positive 1, right? You get positive 1. You can decide to write the 1 or not. It still remain the same. Okay. Now let's come to T. Yes. T. We only have one T. That's this one, and it's for to the power negative 2. To the power T to the power what? Negative 2. So I think now we can find its units. Now we can find its units. Okay. I think there's a mistake here. Yeah, there's a mistake here. Here is negative 1. Sorry. Here is negative 1. So if here is negative 1 and negative 1 plus positive 2, here will be left with what? 1. Yes. It will be left with 1. Yes. It will be left with 1. So we have uh, M. So we have M L T neg 2. Yes. M L T neg 2. Okay. So now we're supposed to find the units. Okay. So the unit for the mass is what? Kg. And that for the L is what? Meters. And T is what? Seconds. To the power negative what? 2. To the power negative. So kg m h to the power 2. So that's the unit for force. Yes, that's the unit for force. That's the unit for force. Okay. So first of all, you simplify it in simplest form like this. Then you find out the unit. So as I said, m multiplying m for multiplication, we add the powers. One is here as well. So m to the power 2 is all over L. And repeat this one here as well. Then when you are done, this one will move to the top. While it is moving to the top, because of the division, we introduce negative. So we still repeat what is here. L to the power 3, t to the power negative 2, m to the power negative 1. Then m, while this one is moving, become what? L to the power negative 2. Yes. So m to the power negative 1 plus positive 2, we get positive 1. Positive 1. So m to the power positive 1. Can decide to write the 1 or not. Let's come to L. For the L, we have 3 here, we have negative 2 here. So 3 plus negative 2, we get positive 1. So L to the power positive 1. You can decide to write it or not. Okay, then let's come to T. We only have one T. That's T to the power negative 2. So repeat it. T to the power negative 2. Then the unit for mass is kg. Unit for length is meters. Unit for time is seconds. But to the power negative 2. I hope you enjoyed the lesson. I'll give you an assignment on a WhatsApp platform so that you do it and send it to me privately.